Good morning, everyone. All the early birds that joined. We're going to give it another couple minutes before we get started, but happy to see so many people were here on time. All right, well, now I'll kick it off to kind of introduce the topics at hand and, let's get this started. So, mastering time series forecasting with advanced techniques is our topic for today. Moving on to introductions and a little bit of the overview. I'm really excited. We have three great folks on the call today. First is Devavrat Shah. He is the CEO and co-founder of Ikigai, but also a professor and a director of statistics and data science at the Center for MIT. He has a bachelor and a PhD in computer science from the Indian Institute of Technology and Stanford, respectively. Prior to Ikigai, Devavrat co-founded Select, a predictive analytics platform for retailers, which he sold to Nike. His work in time series analysis, both at MIT and Ikigai, has been pushing the boundaries of what's possible in forecasting, and was a huge reason that I personally decided to join the company at Ikigai. Secondly, we have Ranjit, who leads our applied AI and solutions team at Ikigai. He'll be walking you through some of our functionality here today. I've known him for years. He has extensive experience in GTM strategy and data-driven solutions. And today is working with our customers to drive transformative AI initiatives that empower enterprises to harness their data more effectively. And then finally, for the Q&A portion, we'll be bringing on Dr. Jahangir Amjad, head of AI platform at Ikigai Labs. He has a wealth of experience as a computer science lecturer, both at Stanford and MIT. Prior to Ikigai, he earned a PhD in machine learning from MIT and made significant contributions at Google, including work on distributed pipelines for statistical inference and the open source data commons project. So we've got three great people here today that are going to walk through some great content. So, first kicking it off will be Devavrat, who's going to walk through just a 15, 20-minute kind of context setting for our Q&A. So walking through the need for forecasting, how we think about forecasting, and how businesses should be thinking about this in a world of a lot of complexity and uncertainty, and then kind of show how we're going to interact with forecasts. We'll show Ikigai forecasting in action and then move to Q&A. So feel free to start shooting those questions over now, and we'll kick it off with Devavrat.
Excellent. Alex, thanks for hosting. Thank you, everyone, for joining. Really appreciate it. Since you're already here, I don't really need to convince you that there is a need for forecasting. But if we just step back for a second, and if we step back and sort of put ourselves in the context of AI helping, AI bringing value to enterprises, really AI starts with data. And if we think from an enterprise perspective, the data is all sorts of tabular time series data about people, about the product, about the finances, and all that. In terms of what enterprises want to do with this data, and AI, of course, is they want to empower their workflows better. If you look at these workflow abstractly, they're trying to do one of the two things, either trying to gain efficiency or they're trying to grow. As they do that, it's one way or the other, some form of balancing act, some form of solving equations, demand matching to supply, the set of skills that you have in your workflows matching to the task that you can done, okay, the cash coming in and the spend that you have on the other side, and so on. Okay, all of us do that, whether it's a small scale or at a large scale. As we try to balance this equation, there are two sides in this. One, which is unknown, uncertain. That's where we want to predict it. That's where we want to forecast it. Because if we can do that better, that would be amazing. Because then we can turn the knobs and plan the control things that we can have and decide how to sort of manage that and match that really well, whether it's from efficiency perspective or whether it's from growth perspective or somewhere in between. And that's where forecasting becomes crucial. And as we think of forecasting, what I want to do here is to talk about forecasting not just as a number, but it's a holistic, cross-functional enterprise workflow that needs a lot more than just forecasting next number. And I'm going to talk to you about that from very much an input-output perspective, from an AI product perspective. Okay. So with that, here is a set of things, and not very much comprehensive, but still, this is a set of things that sort of really matter. On one hand, we have a notion of data, to then understanding patterns within it, to using it to making prediction forecast, to enabling expert in the loop. In AI in enterprise, AI recommendations are things that help expert to make better decision, and AI system can learn more from the expert. It's always AI working with expert rather than AI and expert working differently. And this is where lots of important interaction that needs to happen. On one hand, expert needs to understand what AI means. So that means it has to be explainable. And then AI needs to understand what experts' feedback is so that they can become better. And then finally, when you put all of these things into an enterprise, it needs to be a productions grade system. It's not just a model, it's a product that is needed. We'll talk some of those things. So what I want to do is I want to walk you through these aspects step by step, by walking you through a few examples, and then talk at the end what exactly I mean by explainability. Okay. So let's start with data. Okay. And here I'm taking an example of traditional demand forecasting, but you can think of other data sets as well, whether it's in context of forecasting cash, forecasting revenue, forecasting finances. Let's start with thinking about what we want to forecast here is sales of the products that you are selling. Okay. This is the primary outcome of interest. And it might not be just one dimension. There are many SKUs, many products, many different geography, etc. You're selling it. It's a very, very high dimensional outcome time series that you care about. Now, this outcome time series is impacted by auxiliary data like weather. Things you believe that potentially has impact, but you don't know. Okay. For example, a holiday like Christmas might be related to cold weather and hence might be also related to you buying sweater. And weather is, in a sense, something that is correlated with your sales, but it may not be necessarily driving it. On the other hand, interventions like promotion, you do believe that the price you set, the promotions you run, that actually impacts your sales. And this is what we'll call interventions. So there are these type of information that's out there, which is extremely important related that you have or that outside data has, that you want to bring it as a part of your forecasting plan. But that's not just it. This is more like a temporal aspect. There are spatial information like attributes of product, like what size it is, what weight it is, color, etc. Where you are selling, all of that matters. But then there is also constraint or meta information about product catalog category. Okay, and that's very important because what I forecast at how many clothes are going to sell is equal to how many pants and how many shirts, and how many pants should be equal to how many khakis and how many jeans and so on, right? So there is a consistency across hierarchy that we need. And as we know with any of the experiences that when you go at aggregate level, things are very accurate. When you go at a granular level, things are not that accurate. Question is, how do you keep it reconciled and then use that to actually get better accuracy? Here's a typical workflow in any enterprise where there's a CFO's office, which is trying to forecast how the business would grow or hopefully not shrink over next quarter at an aggregate level. And because CFOs have a very good understanding of aggregate dollars coming in over time, they can actually do this forecasting really well. This is why for example, CFO's office and any of the modern consumption-based pricing business can do forecasting at aggregate level really well. But then the moment you go from sales, the sales team making forecasts out of Salesforce, for example, they're making forecast at what every sales rep and every region would make it. And that may not be consistent. And who is right? Well, it's not about who is right or who is wrong. It's about getting accurate forecasting at all the granularities together so that both things on the field are working well, at the same time, things at the aggregate level working well. And this is just internal view. But then if you're thinking from your customer perspective, that's the other side. There is how much would a given customer sort of consume or need. So that needs to be aggregated. Thinking about time series, there is a natural hierarchy in terms of time as well. What you forecast for a month equals to forecast for weeks equals to forecast for days. So all of these things are there. And then, of course, business specific constraint, like this value cannot be negative. You can never have a negative sale, for example. And that could be a constraint. All of these constraints you want to impose on your data, and this should help you rather than hurt you. So really, this is just data. Very rich spatio-temporal data, a mental model that you should have. It's just like a big cube going in time, space, constraints, attributes. So that's just the data. Now, what do you want to do with data? Well, it's a temporal time series data. So the first thing you want to do is understand the patterns within it, whether it's anomalies because it's unusual, machine error, remove it so that you can do AI-driven data prep better. With time series, things change, dynamics change. It's like somebody asks you a question, should you use 1982's data even if you have available for forecasting tomorrow in 2024? Well, it depends. If 1982 looks like tomorrow, maybe yes, you should. On the other hand, if it does not, you should not. And this is where change points are crucial, both from better modeling perspective as well as change points are important for a business operations perspective. Trends are telling you something about macro pattern. You capture good trend, it will help you forecast better at a long-term level. Seasonality captures the seasonal behavior, and then recency is telling you what you want to forecast next week must depend as a function of this week, and that you cannot forecast 3 months out. You need to know something today. So again, it's a different time scale and different patterns that help you understand it. But then there is something that's sort of really, really important that we do at Ikigai, for example, which we call time to whack. Like taking all sorts of different time series with their spatio-temporal information and mapping them to high-dimensional vectors. This helps you understand what things are similar, what things are not. So that, for example, a beautiful shirt that I'm wearing, so far for calling it beautiful, but the shirt I'm wearing, if there was never sold before, well, maybe it looks like the shirt that Jahangir is wearing. And that's been sold before, and we have historical data about it. We can use now that to forecast what will be the prediction for my shirt. So it's like a new product introduction. Can do many other things too. If you are in the world of AI, machine learning, then you would capture the similarity of time to whack to word to whack, how word to whack sort of enabled now the whole beautiful journey coming now sort of to fruition with LLMs. Time to whack is very much similar building block. Helps you do cohort analysis, helps you do clustering and whatnot. For us, it's crucial as an intermediate point along with constraint and along with properties to do better forecasting, better supervised learning with time series data. In a sense, it becomes crucial features of time series data to do something with it. Okay. With time series data, in terms of prediction, the type of prediction you want to do is, of course, forecast. Not just forecast a number, but also form of confidence interval that tells you how much uncertainty it is. When you get a 90% confidence interval, what it means is that 90% of the time, effectively, you should expect things to fall within that confidence interval. And so if you are looking at from a frequency perspective, 90% of the time, things would fall outside your confidence interval. And that's a good thing. Imputation, missing values, you haven't sold something because of lack of availability or decision. What would have been the demand for it if you had sold it? That's a type of imputation question. Okay. But then you can use time series as a feature to do prediction of labels. So, for example, think of information collected by those smart watches, your vital statistics. And based on that, you might say, hey, you are sitting or you are standing or you're running. Okay. That's a type of prediction you can do. Okay. At Ikigai, for example, we have used this as a feature to forecast based on customers' historical transaction pattern, what would be the chance of their defaulting, effectively proxy for credit scoring. Finally, as we discussed, AI provides answers to experts. Forecasts are provided, but you as an expert may have information inside that you want to incorporate because information is missing from the system, or maybe your instinct says, or maybe machine got things wrong, and that's all are possible. That time you want to change something. You might want to change something at what will happen in terms of sales in Northeast region, but now that needs to be reconciled with the entire country's sales. So that's where reconciliation comes into play to take experts' input with the model learned across. Okay. What if you might have sort of the specific promotions in mind, but if you change it, how would the outcome change? That type of what if scenario analysis you want to do, and that's where sort of intervention data can help. But to do all of these things, at the end of the day, forecast needs to be explainable to you as an expert, right? So here is how we think of our thesis and explainability. And as I explain this, one thing I want you to keep in mind is this classical simple example. So what is the example? Well, if I'm going to recommend you Goodfellas as a movie to watch because you watch Godfather, and I'll say people who have watched Godfather have liked Goodfellas, you'll say that makes sense. On the other hand, because you watched Godfather and you liked it, and I recommend you Barbie, you might say, well, maybe Barbie is a great movie, but maybe not the right recommendation. In similar sense, what is the corresponding analogy, provenance for time series forecasting? So here is an example, and I want you to put yourself into the driver's seat of using this forecast and interacting with it. So imagine that this is the time closer to the end of the year 2022. Think of end of the 2022, December 31st, you are standing, and this is the history you have so far. And now you're trying to forecast for next 6 months of 2023. And here's a forecast that comes out to you. And we say, okay, looking at it visually, maybe it looks fine, maybe not, I don't know. Okay, it's okay, fine. Let's look at what last year it looked like. And last year it looked like this. But then if I go back to last year where it was, in a sense here the pattern is going down, but this here pattern is going up. So in a sense, yes, this last year is very different, but incoming trend was very different. So I might say, okay, can you help me find a trend where incoming trend was similar in the data, and then what is its postfix? And that is this. And turns out there's a similar pattern which matches prefix well, and this is its postfix. I could actually maybe now go and inquire what that is, where it's coming from. But now looking at this gives me reasonable comfort, saying that, okay, it's not too bad. And now I'll go ahead. Now, of course, now imagine you fast forwarded it, you're 6 months later, and you want to evaluate it. Say, well, it turns out that this is the real thing. Actually, this is way better than what you had or you would have anticipated based on last year's pattern. Matches this year's very well. If I look at with the confidence interval that I would have produced, actually 5 out of 6 points fall into it. And this is 90% confidence interval, which is roughly 84% inside, another outside. It's pretty good because as you expect, with 90% confidence interval, 1 out of 6 should fall outside. So this is what I would call a good forecast and the way I would think of it as an explainability. Finally, you want to continue to track your forecast over time. You want to see if it's stable, if it's accurate. So all of that stuff, and really what I would call is some form of a notion of candlestick is a natural way to think about it. There are many other things that you want to worry about when things are in production. You want a full stack view of the world rather than just forecast, just a model. It's the product in production is what you want. Won't go about too much into detail, but I think this is a good place for me to stop this part of the presentation and actually see some of these things in action. So what I'm going to do now is I'm going to invite my colleague Ranjit to take the control and actually take us through things in action.
Thanks, Devrat. I will share my screen. Everybody seeing the screen? Great. Well, thank you, Devrat. That was really insightful in terms of how you walked us through all the aspects of time series forecasting that we need to keep in mind. Um, First of all, also want to say it's great to see people from lots of different industries and lots of different roles. And so hopefully, everything that I will go through today, I want to make sure it really applies to what you really care about from your role. Now, my plan is to actually have a lot of the things that they were showed, from an application point of view. But we need to make sure that, in the end, all of this really has to apply from a business utility point of view. And so here, we're essentially going to walk through some of these examples from a fictitious, consumer electronic company that is selling through multiple channels, has a pretty extensive product portfolio, but in the end, what we want to be able to drive are actionable insights and actions that a role like, let's say, a product planner who has to make sure that the products are in stock can be executed. And so in many ways, as we go through some of the more technical aspects of time series forecasting, I want to make sure that all of you remember and keep in mind that in the end, this has to provide business utility. And in many ways, that's exactly what Ikigai will help you with. Now, getting a little bit more into the forecasting here, you can see that, again, with that fictitious consumer electronics company data that we have, I have a forecasting here based on just historical information. We're seeing that the accuracy is 74% overall. But as David said, we know that there are lots of other elements that we can introduce, which should progressively help us increase the accuracy of what we're really trying to forecast. For example, Devra talked about cohorts or clustering, where you're able to essentially look at the time series of all the different products that you have and really start to figure out which of these are behaving similarly. And creating those cohorts, in this case, we have 6 separate cohorts or clusters, providing that information to Ikigai's forecasting application provides additional information for it to be able to now detect the patterns within the data itself. Now, I can essentially include the product cohorts as part of the forecasting process, and then actually now get a new forecast. And we can see that, the accuracy has increased from 74% to 87%. And so this is a great example of how when you have additional information that you can, essentially it's either correlates or, is an intervention that actually drives the business, including that information can make a big difference in your forecasting accuracy. We also want to look at, the product hierarchy. They were talked about how that can encode a lot of information. In this case, as we talked about, this is a consumer electronics company. It's selling through 3 separate channels, and there are different products, with different levels of hierarchy that are available. Providing this information also can improve the accuracy. Providing information such as holidays and promotions, as Devrat was saying, can really help the model detect, where are those particular bumps, correlated with some of these data points that are included in there. And there's also elements like, weather that we can be including. Devrat also talked about the capability of experts in the loop to look at the data and decide, okay, well, the model is predicting so and so, but is that something that I should be just taking per se? So there are capabilities where Ikigai provides, ways for experts in the loop to detect things like change points or anomalies. You can really explore the data and decide, for example, would you include COVID data, as part of your forecasting or not? That is, a change point in a particular period that we saw due to a lot of different external factors. And so that's where Ikigai provides the capability for experts in the loop just to not take the model's prediction per se, but make adjustments as they see fit. Now, what's really behind all the scenes that's driving a lot of this? So I wanted to give you a quick peek into Ikigai's Flow Builder. And this is more of a data science view. While we saw some of the business views or the business user view, we saw some of the operational views. Here, we're really seeing more of a data science view. And here, this is a very simple flow. You have sales data coming into AI Cast, which is our facet. Think of it as a package of functionality, which is essentially, the model that is doing the forecasting, and you're getting the forecast output here. So you see that it's a pretty straightforward flow here. And the output that you will get out of that is also, going to be something that we'll explore. But before that, we can actually dive a little bit deeper into AI Cast and see that there's lots of configuration that we help you with. There's training and documentation for all this that we help our customers with. But as you can see, within that AI Cast facet, for the data science folks who essentially get trained on all these aspects, there's lots of knobs and levers that you're able to adjust and then really explore, what's really going to provide you the best forecasting. And based on the simple flow, we can see that the output is starting to pick some of the historical patterns. So what you're seeing there in orange is the historical data, and what's there in green and blue is essentially the prediction. It's not great. Let's see, with many of the more complex analyses that Devrat was discussing, what we can do. So this is a more complicated flow. This is a flow which is essentially helping you go through creating the cohorts. And there are lots of different flows you can bring together such that you're essentially able to end up with great forecasts. I also want to bring up one of the poll answers that I mentioned, essentially the capability of collaboration and alignment. That is something that Ikigai is really well suited for. Many of our customers have different teams that are doing different sort of models and predictions around different areas. And we're able to bring all of these together in ways, I said, you're able to get consensus forecasts. So you can think of, ways where different teams could be doing their own sort of flows around their own sets of data with a common data platform where everybody's operating off of the same set of data. And then you can have all that models essentially making the predictions, all of that coming together. And so that's a particular unique strength of Ikigai in terms of being able to help large organizations. But with some of these more complex analysis, now we can actually see a great forecast that we've gotten out of this. The forecast is picking up a lot of the patterns, but I actually wanted to show that here, what you're seeing is a couple of layers. So here we have forecast by region and forecast by country. And so this goes to another extremely unique and powerful capability that Ikigai has, which they were talking about, where not only is Ikigai forecasting at the highest company, sales level, we're helping you forecast at all levels of the hierarchy. So this could be, think of channels, this could be regions, this could be countries, this could be all the way down to the SKU level. And we reconcile it across to make sure that the totals all add up. One particular challenge that we've seen companies deal with when they're reconciling at various levels of the hierarchy is that the totals don't add up. And so with Ikigai, we're automatically looking at the confidence intervals of each level of hierarchy and then picking that up, and based on that, ensuring that we reconcile across the board so that you get forecasts not only at the highest top level, but you also get it at the SKU level. Now, I want to switch back into a little bit more of an application view. Again, all these techniques in the end should be serving a business purpose. And we want to show a little bit more of a deeper dive into time to vec, the technique that Devrat was discussing, where you can have all the different time series data of all the different sales of all the different SKUs being fed into Ikigai. And all of this now essentially gets converted into think of like a higher order sort of vector that we're essentially calculating. Now that's great. Here what you're seeing is the distribution in 3D space of all of these vectors in terms of their time series data, and you can see which of the products are behaving similarly. But again, we want to make sure that this has really a business value coming out of this. And in this case, what we're doing is figuring out a particular product that might be giving out higher than necessary promotions and essentially a higher than necessary discount, where you have other products that are behaving similarly but have lower levels of discount. And so the model's recommendation in this case is being able to essentially reduce your promotion or reduce your discounts such that your margins increase, but your sales doesn't necessarily suffer. And so those are the kind of sophisticated analysis that we're able to help our customers with some of these powerful techniques. And I want to close it out by saying that we provide lots of easy ways for you to be able to bring data in and send data out. We don't expect our customers to only use Ikigai's UI to be able to render a lot of this information. We have customers who will use our APIs to essentially feed the data in, and then have Ikigai in the background do a lot of the complex number crunching, and then have the forecast fed back into their tech stack using our API. So lots of different ways for you to take advantage of Ikigai. And at this point, I will pass it back to Alex.
All right, thank you, Ranjit. Thank you, Devavrat. We are going to move into the Q&A portion of today's meeting. So let me pull that up. Okay. We had a few questions come in to kick it off, but I guess Devavrat, I'll let you introduce our top dog here for Q&A a little more thoroughly.
Absolutely. So, I mean, I think for many of you might know, and for many of you might not know, Jahangir and I have been working together for more than 10 years. He's in my journey started together with our mutual interest in many things, including cricket. So some of you actually, you should, if you're here and you're interested in cricket or interested in the things Jahangir has done, if you search for keywords Jahangir and cricket, there are lots of fantastic articles he has written in press for popular press as well as scientific setting. And one of the things that we did early on was trying to build actually a nice interface, an application at MIT, which was hosted on the website cricket.mit.edu, where you could actually see how you could forecast an outcome of a game as game is going on. And as for those who know sports, it's not straightforward. And he had amazing solution as a part of his thesis. The other thing before that he and was doing was trying to predict price of Bitcoin and see how sort of that prediction is not just good in terms of accuracy. At the end of the day, you put your money where your mouth is. And question is that can you convert the prediction into actually meaningful financial instrument? And actually he did that in one of the papers he wrote, which got best presentation award at one of the AI or machine learning conference, NeurIPS, now it's called NIPS, then in the time series setting. Again, sort of, I don't know whether he he does that for a living. I'll let him respond to that. But I think those are the things that got us started. And I don't know, Jahangir, if you want to sort of just say for over years, something about your love or not so love or a bittersweet love for time series.
Yeah, no, thank you. It's obviously Devavrat was my PhD advisor, and I owe a lot of my professional career to him, of course. But our mutual love for time series did start around that time, and one of the things which I think is what brings all of the audience here, I'm assuming, is also that time series data is number one. It's all around us. It's surprising how often it's maybe overlooked. You talk about forecasting, you talk about predictions in a more classical IID data independently and randomly distributed data in a more machine learning setting. And people forget time series data is all over the place. It requires a lot more care because you can't assume that two data points next to each other are independent of each other. So there is that sequential dependence. And that means that you have to sort of sometimes throw out the existing playbooks of machine learning algorithms and modeling and sort of approach things from first principles. And I say this specifically by saying, when we started the Bitcoin project, we were literally trying to say, we have a lot of traces of Bitcoin price data. Everybody wants to predict stock prices and Bitcoin prices and whatnot. So I was no different. And so this was more of a theoretical exercise saying, could we even do a good job? And what we realized was if you throw just time series algorithms at this problem, you don't get a very good, it seems very noisy. And eventually I butt our heads against this for a couple of months. And then there was a little bit of an insight where it's like, oh, if you transform the data from the regular sort of series structure into a slightly different structure, I don't need to go into the details here, you start seeing that there is a lot more predictability. I could even describe that in English really well. And that is something that anyone who's essentially dealing with Bitcoin data or stock price data or whatever data will tell you that, yes, there is a lot of memory, but there's short-term memory. How can we exploit the short-term memory? Once you model, sort of transform the data, really data transformation, Then we could even go back to the more classical machine learning settings and being able to forecast sort of how things will evolve in the next time step and the time step after. And so a lot of that time was spent modeling. And then that same lessons carried over. We worked together on some retail problems, which are also time series forecasting problems. We worked on, and we did not, even though we loved cricket, I remember that's something that was a mutual passion. That sort of, and that was the highlight of my time as a PhD student, which is that problem and its solution, essentially forecasting how an innings of cricket will pan out, came out as a result of a lot of the tools that we were developing otherwise, not specifically call it time series data, but sequential data. Anything that evolves with time and has a relationship with each other, which, as you know, any sporting game, you can't just take the end of the game or the beginning of the game and completely disassociate it with how you got there. So once that insight came about, which is, oh, how you got here, once I know you got here and I know how you got here, after this, there is a lot of memory in how these things pan out because people play sports all over the place. So we use some of those insights then in a maybe classical time series sense to be able to talk about how we could model this and forecast. And finally, we essentially that allows you to do things like causal inference as well, which is if you're able to tell me what would happen next, but something completely different happened, and that's the beauty of sport, that now allows us to a way to even evaluate, oh, what happened in that little phase of a game that really changed the trajectories completely from each other. And if anything, a lot of what Ranjit and Devavrat was talking about earlier in terms of the scenario analysis, what if analysis, trying to quantify how things evolve, that's really the heart of a lot of some of what's going on there. And so I'll stop here. This was the sort of longer sort of discussion on our learnings, mutual learnings in time series data. Hopefully that's useful for the audience as well. But we can certainly go into the Q&A.
Yeah,
People have asked some great
absolutely.
questions.
No,
Yeah.
I thought that additional color was great. Thanks for sharing. And before we jump into answering the first question, I've got one more question for the audience. So if we could queue up our last poll, um, and it's just digging into really kind of, where everybody's at in terms of doing this. It looked like a lot of folks were joining the call kind of looking for tooling today. Also some focus on collaboration and kind of getting agreement on the initiatives. So I just love to know, like, how far have people gotten with their company's use of AI and time series forecasting? Give a couple more seconds for people to put in their responses between kind of actively using AI and seeing results all the way down to, they exist, but you're not able to get started yet. Um, let's see, what do we got for results? Okay. Looks like people are, I mean, that's generally most of the folks that we kind of meet and work with. That's where they are in their journey when they meet us. So it looks like this audience is kind of right along with everyone else. Um, all right. Well, with that, Jahangir, I'll kick the first question off to you. So, given some of the rapid advancements in large language models and their applications to various tasks, how does Ikigai's approach differ or potentially leverage these models for time series forecasting?
Excellent question, and very relevant as well. We get asked about this all the time. And this is also related to another question that was asked around model parameters and whatnot. So I'll try to answer both of them in the same go. The first thing to acknowledge is that the sort of the language models, when somebody says we want to use a language model for forecasting, what I believe, and I think we collectively believe you mean, is a foundation model, transformer architecture based forecasting. Specifically, they're trained on a lot of financial data usually and time series data. And typically their approach is like you have for the language models, which is zero shot learning, like, which is I've trained it on so much data, it's kind of seen everything that's on the internet, and we have fine-tuned it towards numbers and financial data. So now if I just throw a new series at it, it should be able to sort of auto-complete it into the future. First, I think that's a powerful approach. There are some benchmarks that show that that works reasonably well, especially if you've trained it on a lot of financial data. There seems to be, things that it picks up. Except that's not, we haven't yet found a lot of businesses who would essentially directly go for that approach. Zero-shot learning is saying, I want to learn nothing about your data and your specifics and use whatever I've learned from the internet and essentially project that out. So that's not necessarily a popular approach with businesses. You want it to be really grounded in your data. And that's the fundamental approach that Ikigai takes, which is it almost matters less about the algorithm specifically you're using. We have our own proprietary algorithms. We call them the large graphical models. They're a joint probability distribution learning exercise that we do. And then we sample from it. I will spare you the details right now. Then there's decades of history on statistical time series forecasting models that also work very well in some circumstances. Not all your data will fit into that. Not all of anyone's data fit into any one of these models perfectly all the time. So what we do is we essentially use these models, these algorithms. We run through a sort of your data, learn from your data, which is a history. That's you control that, no other data. And nobody else's model is trained on your data. So that's another important thing. And essentially we run through, we learn, we estimate whatever the model parameters are for specific algorithms. We see what's performing well in sample, out of sample. You can control a lot of those too. And eventually you can decide to sort of pick one or the other, or you can go with many, or as we have found a lot of utility in, don't pick one and apply it everywhere. See what works at different levels of your data. And perhaps that's a much more flexible way of doing forecasting. So that's one answer. We only work off of your data. We use statistical models. We have some deep learning LSTM based models too, but they tend to be more data hungry and not appropriate for all settings. But statistical models, some of the graphical models that we are using are very good with small history regimes with missing data and things like that on your data, basically. And so that's one. And the final answer is, what this allows us is we are not very compute hungry. Foundation models, transformer architectures, as you know, have hundreds of billions of parameters. And so the game there is a completely different exercise. And perhaps, scaling it out, even inference is very costly. Well, statistical models and the graphical models that we have, we run through are very, very, very efficient to run. You don't even need GPUs for it. You can run them on CPUs. You can farm it out across a big deployment, which is what we do, and essentially do a bunch of things in parallel and retrieve the results. Something that might become much harder to do with sort of foundation models. So that's I hope that addresses the question around how they are fundamentally different approaches to doing forecasting.
Thank you. Yes, that was really great. I have another question. This is related to the complexity of data. So, specifically, a lot of businesses have multiple related time series with complex dependencies. How does Ikigai go about reconciling and coming up with an answer in these cases?
Great question. And this was, I think, Devavrat started talking about this, and I spent a couple of minutes talking about reconciliation. We actually find that reconciliation it's great delight for me, because this is one of our true value adds that you will find that we have baked into the platform, which is, don't just produce a forecast for me. If you have, like Devavrat was saying, other information to guide you, which is what businesses do, right? You know the hierarchy and the relationship between different levels of time series. Sometimes they're additive, sometimes they have a different structure. There is no reason not to learn from each other. And so reconciliation is one such approach, where if there are essentially these additive properties or other relationships between different levels of data, so products and SKUs and product areas and things like that, well, if you forecast them all out independently, sure, you'll get forecasts, and sometimes you'll get very good forecasts, but you're only really learning from the time dimension. But in reality, a lot of these processes, if you want to call them that, or time series, have relationships with each other. Some of them, if they are additive, then ideally, you don't want to forecast something that's additive to be completely out of sync with everything that was supposed to add up to that thing, right? And so it's sometimes trickle up, sometimes trickle down. Think of it as solving a large in the statistical language would be a maximum likelihood estimation sort of approach to making sure we enforce some constraints. which are guided by the business, of course, that you know, in terms of how these things may be related to each other. So that's one way, the reconciliation. We have found that to add probably the greatest amount of sort of lift in terms of forecast accuracy, compared to sort of just throwing a bunch of algorithms to the mix, which works well, but this really adds and sometimes adds a lot of flavor to it. And finally, I think something that's related to it is, which also Devavar touched, which was the spatial dimension. Okay, maybe you don't have a hierarchy, maybe you don't have these explicitly defined constraint relationships, but there may be things that behave similarly. They may be co-evolving, they may be lagged evolution. How are those related to each other? Some of our, at least this is where some of our proprietary algorithms come into play, where we essentially put this space dimension in addition to the time dimension to be front and center, and learn not just from the dynamics of how things evolve, but how they co-evolve, I think would be the way to say it, where sometimes, you know, things move in opposite directions, but they may be causally or correlated in other ways as well. So we want to be able to figure those things out for you when we make the forecast. But of course, it depends on the nature of the data. It depends on what your business is like. And no two businesses may end up using the same sort of things, which is why there's a whole suite of things that we make available. I don't know if Devavrat, you wanted to add anything to it.
No, I think I'm enjoying both listening to your answers and also just sort of the questions that are coming up. One thought, Alex, I had before we go to the other parts, maybe we stop sharing the screen for the time being so that we can effectively, we are seeing in the same place till we come to the next one. And also I see there are lots of interesting questions that are coming up on Q&A panel here as well.
Yeah, I see. One is related to, Jahangir, you mentioned specific types of data. We actually have a question related to IoT sensor data and forecasting, if that's something that, Ikigai can handle. And as two-part to this question is data that's got random variations in it.
Yeah. So thank you. This is a great question. First answer is obviously we are, I think somebody else asked this as well. We are generally, we are not tied to any particular domain. It's a general purpose time series forecasting. And there are other regular machine learning tools. Obviously, we don't throw them out. You can use any of them, whatever works for your domain. Now, random variation is the easiest thing to answer. That's how all of this stuff is modeled, right? There may be a lot of variation. And so the question really would be, you're never, hopefully, out to sort of predict noise. And we are not going to help you predict noise because that doesn't make any sense. But usually there is a steady state behavior around which there is noise. And generally forecasting techniques are after the sort of, can we cut through the noise and forecast the steady state effect or the real variation that's going on, which is not perhaps random or idiosyncratic. And then the answer is obviously, then the question is around IoT devices and sensors. Of course, the answer is yes. If you mean in terms of that data is more unique because both it's voluminous, so it's, comes in high volumes. We can handle terabytes of data when it comes to sort of forecasting and learning. We can go close to or near to real time in terms of once you've built the model, you can continue to get new data and make inferences really rapidly. But I believe there's another dimension to IoT data, which is you're not just operating on the months and days and weeks scale, you're going down to a sub-second level. And generally the dynamics of how those things evolve is very different. But if there is, as an example, seasonality, because all these devices, they follow the, whatever they're tracking. If it's a human they're tracking, there is a diurnal range of things that happen every day. We expect us to be able to pick up on that. So our seasonality is not just tied to seasonal days and weeks and month structure, but it can go down to the sub-second level too. Of course, the question would be, what is it that, which data resolution you want to operate under? Are aggregations better? And sometimes we find, and I'll end on this, which is basically, I'm sure this is not news to anybody, which is the finer in time granularity you go to, the more sort of difficult things become. Is there a higher level of aggregation that is really what you're after? Is there a higher level of aggregation that you can reconcile to and use that to guide your forecast? Those are some of the sort of most important, I think, questions that we would love to sort of work with people to answer. But out of the box, yes. This was a long way to say yes. Out of the box, yes. The peculiarities of your data, obviously, you know better than anyone, and that would be a great set of applications to try.
And
Great.
if I just may add, for example, few of the customers we have engaged where IoT style data have come up. I'll take two examples. One is information coming from the energy meters associated with solar energy, and then you want to know at 15-minute granularity at every household how much would be the energy generated and consumed over next 6-month period. That's one type of thing that we've seen works really well, especially along with the weather data and then putting together. And the other one is trying to predict machine fault, part being when things like change point happen in the IoT reading, that's actually corresponding to something unusual happening. Part of it is when you put something for production and you want to see what would be the quality of the outcome would be after 8 hours of manufacturing. Can you just say something based on first 15 minutes of outcome? It's basically a supervised learning on top of your time series or time to whack as a features. And these are some of the things that people have found very useful. But again, as Jahangir said, context matters. So yes, we have got a generic tools and methods available, but context matters.
Great. Thank you. So one other question coming through that I imagine is top of mind for some folks here. Is there a trial and how do I get access to it to be able to kind of see how this works with my own data? So for now, contacting us will be the best way. We'll follow up with everyone directly after this webinar with some content, and we'll be happy to kind of take responses and help people get set up so you can experience this with your own data. We also offer an academy. As you can see, two of our two speakers today here are both out of academia. So educating everyone on AI has been, definitely core to the company since the beginning. So we offer foundations courses and, ways for you to kind of get access and play around with Ikigai. So both of those will be available. We'll be sending a series of links after this call today. And then, of course, we'll be happy to engage with people one-on-one. So we're at about 3 minutes, and we've got a few questions that are all coming in related to specific data types, specific industry use cases. My off-the-cuff answer is that Ikigai is domain agnostic and is meant to work with any kind of time series data. So, we've had folks coming in from a wide variety of industries that we've been working with. Dev or Jahangir, any color you want to add to that, to my short kind of answer on yes, we can do that?
I think you're absolutely spot on. It's a domain agnostic, but also as long as you can model your data as a sequential data time series, and there is something to forecast, right? Not just noise. We expect that the platform has to be able to handle it because we've built all these a big engine around making sure that we can do, identify the best thing to do. Now, if your problem is inherently just noisy and not very forecastable, sure, I don't think anyone can do anything about it. But if there is some structure there, we expect us to be able to figure this out. Now, scale and particular applications, and I see a question here around what you can do on top of it. So if you're in a retail setting, can you say stock outs and reorders and whatnot? There are customers we work with with whom we've sort of gone through this journey as well. And the good thing is, yes, you can build whatever you want on top of it. We have APIs that will allow you to access the results. Now you can convert it and plug it back into your system. If you wanted to do stock out alerts, you want to do other sorts of reorders, you want to do all sorts of things, we can do that. You can report other custom metrics too. So we are a more general purpose generic platform. And so once the forecasting journey is over, that doesn't mean we don't think your journey is over. This is essentially just a intermediate step in helping you make better decisions. So wherever you're making decisions, we're able to port the data there. You can query it via an API, or you can bring your own logic. We have sort of like an alerting framework that's built on top onto the platform itself as well, because this is a common requirement. Then you can plug that right into, and you can go and essentially farm that out however you want. So that's essentially maybe the long answer to we expect to be able to do this stuff and handle it.
Thank you. Thanks, Stat. And this will conclude today's session. Just to let you know, we'll be sending you some resources along with this, the slides and the content for today. So one is focused on around operationalizing AI, so collaborative guide to use with your business counterparts. Time to Vec, a deeper dive into some of the unique capabilities that we offer. And then also time series forecasting that includes some of the benchmarking. So some content for you to get a little more acquainted. And then, of course, if you enjoyed today, please come back. We'll be doing this every 2 weeks, certainly through the end of the year. So really hope to see you all again. And I think that is it. So if you want to learn more, you'll be getting this content shortly, and we hope to see more of you. Thanks, everybody.
Bye.
Thank you.